So go ahead and starting on number 11, it says let a of x equal this and b of x equal this, and wants to know basically on the unit circle here, when does f of x equal g of x? And really this should say a of x, b of x. So a of x is 11 plus 4 cosine squared x equals 12. So these are equal. Equal to each other because it says to right here, and then I just solve for the cosine values. So minus 11 for cosine squared x equals 1. If I divide by 4 on both sides, I'll end up with cosine squared x equals 1 over 4. And then taking the square root on both sides, I end up with cosine x equals square root of 1 is 1 and square root of 4 is 2. And then remember, anytime you get the square root, you got to do plus or minus. So I'm looking where cosine is plus or minus 1/2. So the x values are 1/2 at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So all of my over 3s. So either positive 1/2 or negative 1/2. That's what plus or minus means. So it's all of my over 3s. So x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So when do cosecant, secant, and cotangent have vertical asymptotes? Remember cosecant, like the big answer is, let me put the text box in here. The main answer is when the denominator equals 0. So remember, because cosecant is the same as 1 over sine. So when sine, so I have a vertical asymptote when sine x equals 0, and for secant, that's 1 over cosine. So when cosine of x equals 0, and then cotangent, you can do it either way. Technically, you could say when tan equals 0, but I think it's easier to work with sine, cosine, and we know cotangent is cosine over sine. So when sine of x equals 0. So like an example of this would be, let's say I have, like I could do an example for you if you'd like. So let's say, say we have cotangent, this is an example, cotangent of 5x f of x. So for my vertical asymptotes, I need to write this in terms of sine and cosine. So this is the same thing as cosine of 5x and sine of 5x. So it's when the denominator, so sine of 5x equals 0. That's when I'm going to have my vertical asymptotes. And to solve this, to get the 5x by itself, I'm looking for when sine is equal to 0. And on my unit circle, sine is at 0, pi, and 2 pi. So 0, pi, 2 pi. So these are just some of the vertical asymptotes, but these are going to be the main ones that you're asked about. And then I can get x by itself by divided by 5. So that gives me x equals 0 divided by 5 is 0. Pi over 5 is pi over 5. And 2 pi over 5 is 2 pi over 5. So I'm going to have vertical asymptotes at these x values. Then here, it's asking about the range. Remember the range. So the range for cosecant x and secant x is negative infinity to negative 1, then 1 to infinity. And that's the parent function that you need to know. So you start at your parent function, and then you go in order of HSRV. Let me do that. You go in order of HSRV. So you can ignore the stuff in parentheses because I don't need the horizontal part because range is talking about my y values. Range is talking about my y values. So the first thing that happens to my range is it gets multiplied by 4. So that is then going to give me, so if I times 4, that's going to give me negative infinity to negative 4. Then 1 times 4 is 4, 1. So that's the first thing that happens to the range. So that's taken care of. And then I've got this minus 1. So, because remember, this is a vertical stretch in front of 4, and this is a vertical, translation moved it down by 1. So I've got a minus 1. So that gives me negative infinity. That should be a bracket, sorry. To negative 5, because negative 4 minus 1 is that. Union 4 minus 1 is 3, 2, 30. So when I ask about values of intersection, that happens when they are equal to each other. So intersect means that they're equal. So I'm going to set them equal to each other. 3 plus 5 secant squared x equals 13. And then subtract 3. That gives me 5 secant squared x equals 10. Divide by 5 on both sides. Then at this point, I can't really do much, but I know secant squared is 1 over cosine squared x. 2, and then I can cross multiply. And really, we're like multiply by cosine squared on both sides, then divide by 2. Or really, if it's ever written like this, they're just going to switch places. So you get 1/2 equals cosine squared x. And if you wanted to do this piece by piece, you multiply by cosine, and then to get the 2 away here, you would divide by 2. And that gives you the same thing as what I get here. And then, similar to the one above, you would take the square root, and that gives me plus or minus. The square root of 1 is 1 over the square root of 2 equals cosine. And then to rewrite this, I've rationalized the denominator because I don't know how to evaluate that on the unit circle. So that cancels, like the square root on the bottom is going to cancel out. That's the point. So I'm going to have plus or minus 2 is on the denominator. Then 1 times the square root of 2 is square root of 2. So plus or minus the square root of 2 is cosine. So when is cosine plus or minus 2? Square root of 2 over 2. So that's going to happen at my pi over 4. It's because at pi over 4 it's positive. At 3 pi over 4 it's negative square root of 2 over 2 from x's. And same thing all the way around. So x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So that is, those are the values between 0 and 2 pi where those are equal. On 15, just look at the review sheet, and on 16, it says to work back through worksheet pages 29 through 32. This really should say 28 through 31. It's off by one of my PDF is why I got that mixed up. So I can go through and work like a couple from each page if to help. So let's see. Let's say I'll start on page, is this 28? Yeah, I'll start on page 28. So let's do look at 3. I'm just kind of looking at through the answer key to see the difficulty level of some of them. No, let's do number 3. So let's do 3. It wants it in terms of secant x and nothing else. So something that you're going to need to have access to is these Pythagorean identities here. So let me pull that back up so I can screenshot that. I'm just going to copy and paste this. This is where your cheat sheet comes into play. So I've got 1 minus secant, and it wants me to write it as secant. Well, to do this, I could break this apart and do 1 over sine squared and then secant squared over sine squared. But to get you in the habit of using these formulas here, anytime I see 1 minus, I'm going to use one of these. And the only one that has secant squared is this one. But it has 1 and secant squared on the same side. So to get 1 and secant squared on the same side, I'm going to minus 1. And that gives me tan squared theta equals secant squared theta minus 1. And then you notice it's 1 minus, like I've got a positive 1 and a negative secant. Right here I've got a positive secant and a negative 1. So I need my signs flipped, so I'm going to multiply the whole equation by negative 1. And that's going to give me negative tan squared theta. That's going to give me negative secant squared theta, and then plus 1. I just flipped the signs of the whole equation. I didn't change the equation, I just negated it all. And now, if I flip the order of these on the right side, I've got what I need. So negative tan squared theta equals 1 minus secant squared theta. I just swapped the order. Because now, on my box up top, that's exactly this. So I can plug in that there. So this equals, so I'm working with this now. That's going to be negative tan squared theta on top over sine squared theta. And I'm going to write the negative outside from now on. So negative, and tan is the same, tan squared is the same thing as sine squared theta over cosine squared theta, and then sine theta. And then to keep change, flip this. The numerator stays sine. I'm going to have, I forgot my negative out front. So negative, and then my numerator is sine squared theta over cosine squared theta times 1 over sine squared theta. These will cancel out when I multiply them together, so I have negative 1 over cosine squared theta. And 1 over cosine squared is just secant, so negative secant squared theta. And they wrote it in terms of x, so technically this should be secant x, but x and theta are interchangeable. You would just use the one that they used. I'm just trying to do this quickly. My head is hurting. So let's see. Another one that might be interesting is 6. So 6, it wants it in terms of cosine, and there's no squared or anything, so I'm just going to write this whole thing in terms of sine and cosine. So I know cotangent is cosine over sine times cosine was already in parentheses. So I'm just switching to all sine and cosine. And then cosecant is 1 over sine. So on the numerator, I'm going to multiply these cosines together and get cosine squared x over sine x, and then 1 over sine x, which if I keep change flip that gives me cosine squared x over sine x times sine x over 1. The signs will cancel out, and I'm left with cosine squared. Then I'll do 7 and 8 because these are similar problems. Yeah, I'll do 7 and 8. So it says find sine of 2 alpha. So I need to use the double angle formula here. So the double angle formula just says that sine of 2 of something, like sine of 2 alpha. This is coming from this page of my notes, page 18, my notes. So this right here is sine of alpha and cosine of alpha. And then, so to do this, I can look and say, well, in this case, alpha is right here, and I can find sine and cosine and tangent. So I need sine of alpha and cosine of alpha, which is going to be sine of alpha is going to be y over r. So sine is y over r. So right here, my y is 3 and my r is 5. And my x is 4. So sine of alpha is just 3 over 5, and cosine of alpha is going to be x over r, which is 4 over 5. So that's helpful to just have that like handy. So that's 2 times sine of alpha is, we said was 3/5, and then 4/5. If I multiply all that together, that's going to give me 24 over 25. Then we'll do sine of alpha plus beta. So we need to know what sine of alpha and sine of beta are. So same thing here. X is that, y is that, and r is that. So sine of beta is sine of beta is y over r, so 12 over 13. Cosine is x over r, so 5 over 13. So 5 over 13. So sine of alpha plus beta, I use the sum formula here. So sine of alpha plus beta, you use the top with the top. It's going to be, so that's going to be equal to sine of alpha cosine of beta plus cosine alpha plus sine beta. And then when I write this out, that's going to give me sine of alpha is 3/5 times cosine of beta was 5/13 plus cosine of alpha was 4/5, and then sine of beta was 12/13. So it gives me 15 over 5 times 13 is 65 plus 48 over 65, which simplifies to 63 over 65. Okay, couple from this page. let me do 13. So this is a double angle formula, because you can see it's 4. Actually, let's do a different one. Let's do 17. Let's do 17. So this is a double angle formula. So it's 3 times sine of 2x. The 2 times x tells me it's a double angle formula. So I'm going to write this as 3 times. I know sine of 2 times something can be written with 2 sine theta cosine theta. So I can rewrite it as 2 sine x cosine x. Okay. And then if I just distribute, this is all one big thing. So 6 sine x cosine x. Because there's no plus or minus between these. Like, you don't distribute to both. This is just one expression. So this is similar to C, equivalent to C, I should say. And then for this one, it wants to know which of the following expressions is equivalent to these. So I highlight those on purpose because I know this is going to be one of my sum or difference, but it's cosine cosine minus sine sine. Cosine cosine is what cosine looks like. So that's the formula for cosine. So if it's cosine and cosine back to back, it's going to be the cosine. So I know to write this down. I know that my original, like, unexpanded form was cosine, okay? And then there's a minus here, and on cosine, you can see on top, the top here, so on cosine here, the plus goes with minus. So like, this is basically cosine alpha cosine beta minus sine alpha sine beta. Like, it's using that form. And because this is a minus, I know that the formula was a plus because it's backwards on cosine. So I know I have a plus here. Like, I get that from the minus. And then my alpha is the first one, and my beta is the second one. So 5 pi over 9 plus 3 pi over 9, which gives me cosine of do a couple more. I'll do one more. Let's see. Let's do 6. Sure. So I know cosecant squared minus 1. That minus 1 tells me to do that. And just because these are the problems that I'm doing on the review video, like, you need to study all of the pages on this. Like, you need to work on all the pages. Don't just think these are going to be the ones exactly like it on the test. Like, I'm quite literally picking pages at random to help you see some of these. So cosecant squared is in this one right here. But to get it to look like that, I need to minus 1 on both sides. And that gives me cotangent squared theta equals cosecant squared theta minus 1. So I can plug in cotangent, like, that gets cotangent by itself, and I can put cotangent right there. So cotangent squared theta over cosecant squared theta. And now I can write these in terms of sine and cosine. So cotangent is cosine squared theta over sine squared theta over 1 over sine squared theta. And then keep change flip. So cosine squared theta, rest is given out, over sine squared theta times sine squared theta over 1. And when I multiply those out, those are going to cancel out. So I'm just left with cosine squared theta, which is choice. In my box here, this is choice F.